Let's say we're given this stoichiometry question in a chemistry exam. We could answer it in this way. We use proportion to calculate the number of moles of sulfur trioxide needed, and then we use a formula to convert this into its equivalent mass. Or we could answer the question with a single generic proportion method, such as the unit factor method. We give the question in equation format and we multiply that by a conversion factor, which is the proportional relationship between the given and required variables. I'll get back to those two different approaches in just a moment, but first, thank you for joining me for this presentation. I'm only in the early stages of data analysis for this particular data for this study, so I'm not yet able to do justice to this title. However, I think that you should find the background to this study interesting, and I'd also appreciate your feedback concerning the approach that I'm taking using the preliminary data analysis. This is an outline of the presentation. I'm going to give you a brief background to the study by telling you about the workshops at which I collected data, and also the prior publications that I have from this data, and how this study builds particularly on the most recent of these. I'll then present my research questions and some information about my sample and the data that I've collected. And after that, I'll present some preliminary analysis, which I've done. The purpose of this preliminary analysis is not to answer the research questions, because at this stage, I've only analyzed a small fraction of the post-test data, and so I'm not in a position to answer the research questions. But rather, the purpose is to explore ways of representing the data and to use this opportunity to ask for your input before I embark on the very labor-intensive process of data coding and analysis. In 2017 and 2018, I ran 7 two-day stoichiometry teacher workshops throughout the Free State Province in South Africa. The teachers wrote a pre-test at the start and a post-test at the end of these workshops. Each test was composed of 16 multiple-choice questions, which were primarily conceptual, and 4 calculation questions for which the teachers had to show their working. I already have 2 articles published from this data, an article in the Journal of Chemical Education based on the pre- and post-multiple-choice question data, and an article in Chemistry Education Research and Practice based on the teachers' answers to the pre-test calculation questions. In this current research, I compare the post-test data for the calculation questions with that from the pre-test. And I do that to see if the workshop was effective at improving the teachers' use of proportion. In the workshop, I introduced the teachers to the generic proportion method, the unit factor method. Now, to understand the point from which I started for this research, it's important to first understand the work that it's founded on. So I'm going to go back to the video abstract that I started playing. Hello. I'm Angela Stott from the University of the Free State South Campus, and this is a short video abstract of my research paper about South African physical sciences teachers' use of formulae and proportion when answering reaction-based stoichiometry calculation questions, published in Chemistry Education, Research and Practice. In this paper, I show that South African physical science teachers, and probably also physical science teachers from other developing countries, greatly underutilize proportion. 13% of my 171 physical sciences teachers sample fail to recognize the need to use proportion in any of the 4 reaction-based stoichiometry questions that I used. 25% recognize this need consistently, and 62% recognize the need for proportion for some, but not all, of the questions. Further, I found that the discipline of writing down a formula and substituting values into it helped those that were less competent with proportion to get some process marks, but was otherwise of insignificant value to solution success. But let's get back to this question and these 2 solution strategies. This one, which uses a generic proportion method, makes no use of formulae, because while use of proportion is essential in reaction-based stoichiometry, use of formulae is not. According to the South African Curriculum and Policy Statement, CAPS, either of these methods should be acceptable. The problem is that the way marks are awarded in exams at present disadvantages a generic proportion method. South African marking guidelines and exam reports focus explicitly on formulae, but only implicitly on proportion. Might this be giving the wrong message about the relative importance of formulae and proportion in stoichiometry to South African learners and teachers? We know that in the developing world, teachers' subject matter knowledge tends to limit what they can teach. And their subject matter knowledge is even largely limited by what they believe that they are expected to teach, which tends to be teaching to the exam. So by measuring what teachers in such contexts know, we can deduce what they probably believe is important and what they probably teach their learners. That's why it's valuable to investigate the extent to which teachers recognize the need to use proportion in stoichiometry calculation questions, and also to what extent that and the extent to which they provide formulae and substitutions explicitly in their own solutions affects their stoichiometry solution success. Based on this research, I recommend firstly, that stoichiometry teacher professional development opportunities in the developing world need to stress the value of proportion, and they need to develop teachers' competence with proportion. Introducing teachers to a generic proportion method, such as the unit factor method, might help direct stoichiometry focus where it belongs, to proportion, rather than to formulae. Secondly, examination marking guidelines need to be changed to allow for the use of a generic proportion method with no penalty for using such a method instead of one that uses formulae. The main message of this work is that stoichiometry is about proportion, and so proportion is what needs to be stressed in examinations, in teacher workshops, and in the classroom. Please read the full article and also share it and the video abstract. Find a link to the article below, as well as a link to the research page on my website, learnscience.co.za. That was a video abstract of the work on which this study was founded. I included it here to give you some background to this particular study. These are the research questions for this study. I wanted to know how the teacher's use of proportion changed as a result of attending the workshop. In the workshop, I introduced the teachers to the unit factor method, so I was particularly interested in the teacher's uptake of this method. I was also interested in the relative success of various solution strategies the teachers used in the post-test. These are some of the characteristics of the full sample that I will eventually draw on for the study. I ran these 2-day workshops throughout the Free State. The Free State Physical Sciences subject advisors extended an open invitation to all physical sciences teachers in their areas to attend. 220 teachers attended, but only the data of those teachers who provided informed consent to the use of their data and who completed both pre- and post- and biographical survey data are included here. However, for this presentation, although I've analyzed the pre-test data for this full sample, I've only analyzed the post data for 13 teachers so far. In this study, I focus on the teachers' written answers to the 4 calculation questions, and particularly on the difference in their use of proportion and the success of this between the pre- and post-tests. The 4 calculation questions making up the post-test were similar, but not identical, to those in the pre-test. Corresponding questions in the pre- and post-tests also had the same mark allocation formats. The participants had no access to the pre-test questions after they'd written the test, and we also didn't discuss these directly during the workshop. All these considerations increase the comparability of the pre- and post-tests. For both the pre-test and the post-test, there were 5 relevant formulae that could be used, and for each of the 4 questions, proportion was required. I'll return to that in a moment. This graph shows the prevalence and success of proportion usage for the pre-test for the full sample of 171 teachers. These are the 4 questions. The green bars show the fraction of teachers that used proportion and got the correct answer. The pink bars show those that used proportion but did not get the correct answer, and the orange bars show those that did not use proportion at all and therefore also failed to get the correct answer. Finally, the black bars show those teachers who didn't attempt the question. As I said in the video abstract, this graph shows that the teachers severely underutilized proportion. It also shows that recognition of the need to use proportion is question dependent, and that although the failure to recognize the need of proportion is a major problem, it isn't the only problem that prevents these teachers from obtaining the correct answer. This is the same kind of graph, again for the pretest, but now for only the 13 teachers included in this preliminary analysis. And we see similar trends to the full sample. And this is the post-test graph for these 13 teachers. There's clearly a drastic decrease in the orange bars, suggesting that the intervention was effective in making the teachers aware of the need to use proportion when answering stoichiometry reaction-based questions. There's also an increase in teachers obtaining the correct answers, shown by the green bars, although this increase is less pronounced than the increase in use of proportion, suggesting that other issues besides proportion also need attending to. Now remember that I said that there were 5 relevant formulae which could be given and substituted into, even though, as I explained in the video abstract, use of a formula is not actually required for obtaining the correct answer. In contrast, it isn't possible to get the correct answer without use of proportion for these kinds of questions. I assigned each teacher a score out of 4 for proportion usage, 1 mark for each question. And that was based on whether they used proportion, not whether that use was correct or not. And then I also assigned each teacher a score out of 10 for use of formulae, 1 mark for explicitly giving each of these formulae, and 1 mark for explicitly substituting values into each formula. I then plotted the teachers' strategies on these 2 axes based on those scores. This axis relates to the formula and substitution score out of 10, and this axis relates to the proportion usage score out of 4. Each of the 171 teachers occupies 1 point on this graph, and all the teachers at each point are aggregated together to form the bubbles, so the bubble sizes represent the number of teachers. I then arbitrarily divided this into these 4 quadrants and described these strategies with these names. Those that used proportion to a high degree, but provided formulae and substitutions to only a small degree, showed a proportion-reliant strategy. Those that did the opposite, used proportion to a low degree but diligently provided formulae and substitutions, showed a formula-reliant strategy. And those that did both to a high degree showed a formula and proportion strategy, and those that did both to a low degree showed a minimal strategy. In the video abstract, I referred to generic proportion methods, which can do away with the need for formulae. The unit factor method is an example. A person who uses such a method consistently would appear up here in this graph. In the pretest, I only found that 1 of the 171 teachers used the unit factor method, and that 1 didn't even use this method for all 4 questions. Here we see a similar graph, but only for the 13 teachers in this preliminary analysis. The orange bubbles represent the pretest strategies, with most falling in the minimal category. The green bubbles represent the post-test strategies. All show a high use of proportion, and all but 1 teacher now falls in the proportion-reliant category, with most now using the unit factor method, which they were exposed to in the workshop. I measured the success of the various strategies in 2 ways, according to whether they got the answer right and according to the number of marks obtained, which included process marks. In the prior study, I performed statistical analyses between the 4 strategies for both of these measures of success, and I found no statistical significance for either of these measures between these 2 categories, which both used proportion to a high degree, but differed in the extent to which they used formulae. However, both these groups performed significantly better in both achievement measures than these bottom 2 categories, which used proportion to a low degree. Regarding getting the correct answer, these 2 didn't differ significantly from one another, but the teachers in the formula-reliant category did manage to achieve more process marks than those in the minimal category. For the current study, it's premature to perform any statistical analysis, but this is a graph showing the pre-post comparison according to strategy. This time, the bubble sizes represent the marks obtained out of 16. We can see clearly larger bubble sizes for the higher proportion usage categories than the lower proportion usage categories, matching the previous findings. And we also see clearly larger bubble sizes for the post-test than the pre-test. And this is a similar graph, but now with the bubble sizes representing the score of correct answers. Finally, I reflect on the way forward with this research, and I call on you to provide me with some feedback. Although I can't yet answer these research questions, I do believe that if I continue with the analysis that I've started, as I've presented it here, I will be able to answer them. The analysis I've been doing so far has really been a replication of that which I did for the pre-test for the paper published in Chemistry Education Research and Practice, but with the added element of comparing the post and the pre-test with one another. I now appeal to you to give me feedback about whether you think that this is the right direction to take. Please leave me comments below or give me some feedback directly. Please also take note of the links to the prior articles given below. The article in Journal of Chemical Education is not open access, but I do still have some of my allotted free links to give away, so contact me for one. Please visit my website, learnscience.co.za. I've included the direct link to the research page below, and please don't forget to leave me some comments below.